Good evening, one and all. And this is the fifth day of this ATAL FDP in this series. Today, Dr. Rajendra Kumar will be deliver his valuable session. Before that, I would like to just brief them. Sir, am I audible?
Yes, sir. You're audible.
Okay. So, welcome, Dr. Rajendra Kumar. Rajendra Kumar is an accomplished academic and researcher, currently serving as a professor in the Department of Computer Science and Engineering at Chitkara University, Chitkara, Punjab, India. With over 16 years of teaching and research experience, he has developed deep expertise in computer science and engineering. Dr. Kumar holds a PhD in computer science from IK Gujral Punjab Technical University, Punjab. He also earned an MTech degree from Chaudhry Devi Lal University, Sirsa, and MBA from Guru Jambukeshwar University of Science and Technology, Hisar, and BTech from SCTM Technical Campus, Kaithal, Haryana. His diverse academic background reflects a strong foundation and interdisciplinary approach to research and innovation. He has authored 7 international books and contributed to 8 books chapters published by renowned publishers such as IEEE, Elsevier, and Scopus Index volume. In addition, he has published more than 30 research papers in SCI, Scopus, and UGC Care listed journals. Dr. Kumar is also an innovator holding 4 patents from Australia, the UK, and India, and 2 Indian copyrights for his original literary works. As a researcher mentor, Dr. Kumar is currently supervising 3 PhD scholars and has guided 7 MTech dissertations and over 60 BTech projects. His academic influence extends beyond his institution, having served as an external expert for PhD research on 9 occasions and evaluated over 20 PhD theses at various universities. Dr. Kumar is actively involved in the academic community. He has organized 6 sessions and international conferences, delivered numerous keynote addresses, and served as senior chair at multiple international events. He has reviewed technical books for reputable publishers like Springer Nature and Scopus Index outlets. His contributions to curriculum design further showcase his commitment to academic excellence. He has received several honors, including the Inspiration Award from Wellinkar Institute, Mumbai, for securing second place in the Smart India Hackathon 2019 and achieving first place in SIH 2022 held at Birla Institute of Technology, Mesra, Ranchi. Dr. Kumar continues to contribute significantly to research, innovation, and quality education in computer science and remains dedicated to shaping the next generation of technology professionals. I warmly welcome to Professor Dr. Rajendra Kumar. Please, over to Dr. Rajendra Kumar.
Sir, my voice are audible to you?
Yeah, audible, sir?
And screen, my screen, sir.
Yes, also,
Okay,
please proceed.
okay, sir. I would like to express my sincere thanks to AICT and Global Group of Institute, Amritsar, Punjab, for inviting me as an expert for the second session of this FDP. It was an honor to be part of this insightful and well-organized event. My heartfelt thanks to the coordinator, Dr. Arvind Devangan Sarji, and the core coordinator of this FDP, Dr. Vineet Sir, for their excellent planning, warm hospitality, and the continuous support throughout the program. I also extend my appreciation to all the organizing members of this FDP for their dedicated effort in making a session successful. Today's my session topic is about the AI for energy efficiency and sustainability in the industry 4.0. So this particular slide is the base of my session about the AI for energy efficiency and the sustainability in industry 4.0. The industrial sector accounts for nearly 37% of the global energy consumption and 24% of the CO2 emissions. So industry is one of the, you can say, the largest energy consumers across transport. We are having buildings, industries, and we are having different type of processes like heating, motors, compressed air are the major contributors. So high operational cost, volatile energy markets, regulatory pressure like carbon limits, kind of reporting, and then the reputational risk also are there. So why this matter for the engineers? Because the relatively smart efficiency gains across many processes translate into the larger absolute saving of the energy cost and the emissions. So even 5 to 10% efficiency improvement in a manufacturing plant can cut costs substantially and reduce the carbon footprint. That's the why this topic is very crucial today. So as we are in the industry 4.0, integrated the AI with the IoT, big data, cloud computing, edge computing, and then a different type of interdisciplinary, you can say research area for the smart energy management and sustainable production. So if we talking about the some kind of usage of the different latest technologies with the industry 4.0, we are having the IoT and sensors which are used for the collect fine grained data, power meters, temperatures, vibrations, and we are having flow rates, occupancies. Without data, you can't optimize real values. Okay. So second one is we are also talking about the big data platforms like these platforms are used to store and process high volumes of the data. So we have to the time series and of the event data from many machines and the sites. Cloud computing also provide the scalable storage, advanced analytics, and we are having a centralized kind of model training where we can have the good of the cross plant insightful from the from using this type of technologies. We are having also the edge computing runs in the inferences closest to the devices. We are having low latency of the control loop. And if you're talking about then we have the reduced kind of bandwidth and the preserved privacy. So we have to also use the AI machine learning that turns the data into actions. We can also prediction and if is there any anomalies there, then we can detect with the help of the AI machine learning technologies. We can also optimization our result. We can control the different type of activity that are part of the manufacturing plant and part of the smart industries. So our aim to is to reduce waste, optimize the resource use, and the minimize the environmental impact. Now we start with the different type of topics that relate to the energy efficiency and sustainability. So first we start with the foundational concept. Then we trying to have the information about the energy efficiency. What is energy efficiency in context of the industry 4.0? Then we discuss about the sustainability because these two are the major topics of today's section. Then we are having also talk about the AI for energy efficiency, how we main role of the AI in context of the energy efficiency as well as for the sustainability. And these roles transform the industrial transformation or industrial role from 3.0 to 4.0 and with the latest technology. Sorry. Then we also talk about the global leaders from the world and that are initiatives, different type of initiative driving AI for the energy efficiency as well as the sustainability. In last section, we discuss about the future of the AI in respect of the energy efficiency and sustainability in Industry 4.0. So start with the foundational concept. Now here is talking about the background and motivation of this particular topic. Then the first point is we have to discuss about the industrial sector as the largest energy consumer. So industries like such as the manufacturing, side of mining and cement, steel, different type of industry like textile, chemicals, and related to the oil, gas. So these different type of industry require massive amount of energy for their operations like heating, we are having cooling, transportations. We are having also material processing, uh, running machinery and power. We have to also powering the different production lines. So globally, industry consumes more energy than the household transport, like and the commercial sector. This particular manufacturing sector include electricity, natural gas, coal, petroleum. High energy demands lead to the directly to the high operational cost. So increase environment, this will increase the environmental impact. So this is why the industrial sector is often considered as a priority target for the energy efficiency and sustainability initiatives. Next, we are also talk about the contribution of the greenhouse gas emissions, that is also known as the GHG. This industrial sector is also, you know, one of the biggest source of the greenhouse gas emissions, especially CO2. So as per the IEA, that is the International Energy Agency's 2024, so industries are the responsible for around 37% of the total global final energy consumptions and 24 of the total CO2 emissions. So these emissions mostly come from, different type of fossil fuels burning from the thermal energy like boilers, furnaces, and and we are having a use of the electricity from the carbon incentive rates. We are also having in terms of the chemical processes, cement, like and steel making factories. So industrial waste generation. So this fuel burden high energy use and with a high emissions. So it makes industry a critical area for the climate mitigations. Next, we can also check about the net zero and the sustainability goal matters. So countries worldwide have committed to the net zero emissions. So many by 2050 and India also committed to 2070. So to achieve some of the goals related to the current topic, that is industries must be reduce the carbon emissions, shift to the cleaner energy sources, and improve the energy efficiency. Also, we can also have the some of the government and then the industries organization, different type of organizations, some have to face the environmental regulations, rising carbon taxes, pressure from the customer as well, and global supply chains. So this type of things, industries are increasingly adopting the advanced technologies to reduce the emissions without compromising the productivity. AI also have the impact on this kind of things. They are like in case of AI-driven energy optimization in the Industry 4.0. So Industry 4.0 refers to the fourth industrial revolutions where we use latest technologies like AI, machine learning, IoT, sensors, smart devices, big data, cloud and edge computing. and we can also have the digital twins, cyber physical systems. So these technologies make you know, possible to collect different type of data. We can also analyze these data and act according to the real-time energy data. Rather to have the fixed silo where the old type of data, we have the real-time data, so we can use these technology for that. So AI-driven energy optimization include the predict. We can also predict the energy demand. We can reduce the peak energy usage if running into the manufacturing plant. We can also optimize the machine operations to use the less energy. We can identify energy leakage if any energy leakage is there in case of the manufacturing plant. Is there any inefficiencies out there? Then we can also find out that with the help of the latest technologies. We can also schedule the high energy task if any task related that that are using the high energy. So we can also identify that and during the low tariff periods. We can improve the processes control to reduce the fuel and then electricity consumption. We can also integrate the renewable with the storage as well as the smart grids to lead the outcome that is lower energy bills. We can also reduce the CO2 emissions. Higher operational efficiency we can do with the help of this technology. We can increase the machine life and better regulatory compliances if we are having in case of the because these are depending on the country to country. But in case of India, we are having multiple initiatives are there regarding today's topic. So main thing is that why AI is important, or it is not becoming a necessary part, not a choice, but a necessary part of the manufacturing. So traditional methods for the energy management rely on the manual monitoring and the periodic audits. So these are kind of the drawback, like these are slow and we are having error prone kind of data, limited in scope if we talking about the larger level of manufacturing plant, then not a real kind of, but because person have to give the data to some higher authority person. So time consuming process is there, but modern industries plant like in case of industry 4.0, we are having generate you know petabyte kind of energies data or processes data out there. So only modern technologies, the mixing kind of energy, we are having the AI to analyze such massive amount of data, and not only massive amount of data, but in real time data streams, and continuously optimize the performance of the companies. Different kind of companies manufacturing plant are there, but we can use the different latest technologies by depending on the situation or depending on the manufacturing plant. And this particular slides shows the key goals and the mechanism. We have a particular agreement of the Paris climate that is totally depending on the climate, Paris climate agreement. So the Paris agreement sets the comprehensive international framework to tackle the climate change by reducing the greenhouse gas emissions, and we can enhance the resilience and support the different developing nations. So mainly its goal and the mechanism ensure that global cooperation between different amongst the different countries, accountability of different countries, and we are having a long-term sustainability of different terms related to different frameworks, concept related to the industry 4.0, where we ensure that we have a better sustainability and low energy emissions from the manufacturing plants and then in smart manufacturing companies and the different type of sectors. So basically, the main goal is to have the limit of the temperatures from the companies. So to keep the global average temperatures rise well below the 2 degrees Celsius above the pre-industrial levels, and pressure effort to limit to the 1.5 degrees. So why it matters here? So a 2 degrees Celsius rise caused the severe climate disruption from the heat waves like there is sea level rise and kind of crop failures. So of 1.5-degree limit reduce the risk significantly. So mechanism from the different type of countries must reduce these emissions rapidly through different type of energy consumption. Like we have to transition from the renewable energy sources. We have to improve the energy efficiency. We can also facing the outcall. We can also electrifying the transportation systems, and we can also main thing is that we have to preserve the forest. The next is NDC is there. This is known as a nationally determined contributor. So each country sets its own national climate target that is known as the NDC for reducing the emissions and adapting to the climate impact. So how NDC work here? So energy, every country have to, regardless of its development status, submit the NDC at every 5 years. So each new NDC must be more ambitious than the previous one. The progressions, this is known as the progression principle. So NDC include the strategy like the renewable adoptions, emissions caps, energy efficiency, forest conservation. Then we can have the building climate resilience, the adaptations. So to strengthen the ability of the countries, especially vulnerable communities. So we have example of the adaptations measures like the climate resilience agricultures, early warning system for the cyclones. We have the heat wave management systems. So these are the mechanisms that country use to develop the national adaptations plan that is known as the NAP. We can also use climate finance to support the developing nations to ensure that financially, technical, and then the capacity building support for the developing countries so they can reduce the emissions and adapt to the climate impact. This is about the Paris Agreement. This video is about the Paris Agreement. In case of the foundational concept, we are having the evolution from the traditional to the industry 4.0. Earlier in my first day lecture, we also discussed about the evolution from traditional to the industry, a little bit about this topic. The evolution of the industry over the past 2.5 centuries has progressed through the major stages. And these four major stages are Industry 4.1 to Industry 4.0. Each transforming the very goods produced and the managed delivered from Industry 4.0 began in the late 18th century with the introduction of the mechanizations powered by the steam engines. water turbines, the shift from the manual labor to the machine-based productions, then the rise of the factories, mass-scale manufacturing for the first time. The second industrial revolution, Industry 2.0, emerged in the late 19th and then early 20th century with the discovery of the electrifications enabled faster and more reliable machines, while assembly lines and the divisions of the labor revolutionized the mass productions. We are having mass production in case of the Industry 2.0. Industry 3.0, known as the digital revolution, so begin in the 1970, adoption of the electronics, computers, automations, technology. We are having PLCs, that is the programmable logic controller, robotics. IT system allowed industry to automate the repetitive task in case of the industry 1.0, but in case of industry 3.0, we are having the automate these repetitive tasks so that we can improve the accuracy and transition from purely from the mechanical systems to the computer driven automations. Finally, we are having in the current 4.0, the current phase of the industry development, where we integrate the latest technology like AI, Internet of Things, big data, cloud computing, and different type of other cyber physical systems and technology. So this is also the part of the foundations where energy challenges are there. So the global energy landscape is undergoing a major different transformations, several critical ones to continue the shape of the industries and then the national energy strategy. So one of the main significant challenges here, the transition to the renewable energy. So as countries strive to shift from the fossil fuel to the cleaner sources such as the solar one with the wind and then the hydropower. So although renewable adoption is growing the rapidly, but issues like storage limitations we are having and the high initial cost of the hinders are smooth complete transitions. So at this the same time, energy demand continuously to rise due to the energy industrial expansions, urbanizations, digitalization is one of the things here, and the increasing in the electrifications of different transportations and manufacturing process. So meeting these rising demands with the sustainable sources remains a key concern. So another challenge is the price volatility that fluctuations in global oil, gas, electricity. So market create the uncertainty for the industries and then the consumers. So political conflicts also play important role here. Supply chain distribution is there, and we are having the seasonal variations that often lead to the unstable energy prices. The next one is we are having the grid stability, also to become a major concern in case of the modern power systems, especially as a renewable sources that include the variability in the supply. We have to integrate the distributed generations. So finally, we have to also energy security is also the growing priority for the nations. So as dependence on the imported fuels for the risk related to the geographical tensions, we are having the supply distribution and the resource. So we have to ensure that we have a stable, diverse kind of and the sustainable energy supply that has become the essential of the economic growth, as well as we are having together, we have to tackle these challenges with the latest technologies. As in case of the energy, we are also having some of the challenges with the sustainability. So we have to discuss about the sustainability challenges. Sustainability efforts across the industries and the nation face multiple interconnected challenges and hinder progress toward the long-term environmental and the social well-being. So one of the main critical challenges here is the climate change. So driven by the rising greenhouse gases emissions that result in the extreme weather events, heat wave, floods, distribution of the ecosystems, economies. So alongside this, we are having also the resource depletions that has become a pressing concern as the growing global populations, industrialization expert immense pressure on the natural resources such as water and the mineral, the fossil fuels kind of thing. Then we are having also, in, additionally, industries have to also navigate the increasing regulations, stakeholder expectations as governments, you know, different type of we are having customers, investors also demand the cleaner productions. So we also want the transparency and the responsible management practices as well or not. So the inadequate infrastructure is also the main challenges in case of the sustainability, especially in the developing regions. So where are the outdated energy systems are there, waste management facilities, transportations network also not up to the mark. Digital systems limit the adoption of the latest technologies, which enhance the sustainable technologies. So we have poor kind of infrastructure also affect the ability of the communities to withstand with the climate impact, to access modern eco-friendly solutions. Last one is the social equity also ensure that the benefit of the developments, including the cleaner energy, education is one of the main points, technologies, economic opportunity also there, they are distributed fairly across all the segments of the society. So these are the main challenges in case of the sustainability. So we have to tackle these challenges with the enhancement in case of the energy efficiency as well as with the sustainability. So in case of the energy efficiency in industry, what is the meaning of energy efficiency in context of industry 4.0? So energy efficiency in industry 4.0 refers to the intelligent and then the optimized use of the energy through the integration of the advanced digital technologies such as AI, Internet of Things, cyber physical systems, big data analytics, digital twins, smart sensors. So in traditional, if we compare this with the traditional one, so in case of the traditional industry, without the use of the advanced technologies like AI and other, so energy waste occur due to the limited real-time visibility, manual monitoring are there, and the reactive maintenance practices are there. But in case of Industry 4.0, this transforms the approach to creating the high connected and then automated environment where data is continuously collected, and this data is not smaller one. The huge amount of data collected. So the main thing is how we analyze. So industry 4.0, we have the different AI machine learning models are there. So we have to analyze to improve the efficiency of the machines. Different kind of processes we can also analyze. We have to also entire production lines we can also analyze. So energy efficiency has important and become a core part of the industry 4.0. So because it directly for the cost reduction, environmental sustainability, and improve operational performance. So by optimizing the energy usage, industry can significantly lower their operating expenses while reducing the greenhouse gas emissions, which can be, you can say, help to meet the nations and the global environmental target. So in case of the real-time energy monitoring system, ensure that different type of machines operate under the optimal conditions. We have a predictive maintenance that prevent the, you can say, the breakdowns that lead to the excessive energy consumption. Regulations around the energy use and the emissions are becoming stricter. And we have industry 4.0 technologies in case of the industry 4.0. Then we have enabled the companies to comply with the accurate energy tracking and automated the reporting systems. So these technologies not only enable the energy efficiency in various way, IoT sensors provide the real-time data on the energy usage of the machines, enable the dynamic kind of adjustment if we need that, and we can also have the early detection of the wastage. If any kind of wastage is in there, then we can also early detection of that. AI also and the machine learning optimize the use different type of algorithms to analyze large volume data, operational data to predict any kind of energy demands automatically. With this system, optimize machine scheduling, ensure the minimal kind of energy losses. So digital twin we can also use to that allow the industry to simulate the test energy efficiency before implementing them. We can also reduce the trial and energy consumption. Smart grid are there, so demand response systems help industry to reduce the energy usage. In case of the industrial energy efficiency, we have the key technologies in Industry 4.0 energy optimizations that optimize the energies. So Internet of Things, in shorter way, we discuss about IoT, that IoT devices continuously monitor the electricity, heat, steam, fuel, machines, and then energy usage. Sensor detect the if any kind of abnormal leakage are there. Machine health uh, data, we can help the avoid energy wastage if we can there. IoT dashboard integrate the plant-wide consumptions into a single platform for the visibility. Then AI algorithm analyze the historical and the real-time data to forecast any energy demand. AI automatically adjusts to the machine speed, load, temperatures, pressure of the to minimize the energy wastage. This is in case of the traditional methods, traditional companies manufacturing. This is very difficult task. But in case of AI, they can predict the maintenance, reduce energy spikes from the worn out the components. Any malfunctions is there related to the machines. So with the help of the AI-enabled optimizations, help industry to shift from the processes to the low-tariff hours. Automation and robotics. Automated systems reduce human error, prevent any unnecessary energy consumption activities. Robotic ensure the consistent performance, reduce the idle time and the operation delays and there. Then also we are having the collaborative robot that is known as the cobots to consume less energy than the traditional industries robot. We are having the solution of this problem like cloud-based energy management systems are there. So cloud platform collect the data, analyze energy data from the multiple locations. So not depending on the company locations from the outside, from remote locations, we can handle the data, large amount of data of a company. So manager can monitor the factory performance with this anytime and enable the fast decisions on the basis of the analytics algorithm. So cloud analytics provide energy dashboard like and the tracking systems, automated reporting. Integration with a smart grid allows the load balancing and then demand responsive strategies. How energy 4.0 reduce the energy cost? So earlier we are having some of the challenges. Then we using the AI technologies, we have efficiency in case of the energy. Then how industry 4.0 reduce energy cost? So in case of energy cost, we have a real-time energy monitoring system, smart metering. So IoT energy sensors continuously track the electricity, heat, and the machine level consumptions across the factory floor. These ensure they help to identify is there any energy usage areas such as inefficient motors are there and overloading machines are there, leaking compressed air systems. So smart meters provide the detailed minute to minute energy data to the engineers. So this kind of things enable the industries to compare energy usage across the different type of departments, shift machines. So data collected from the sensor is sent to the AI-powered dashboard, where analyze the patterns and automatically suggest the saving actions, so that lowering the machine speed, then optimize the cycle time, turning off the idle equipment is there any, then the real time visibility to ensure the energy decisions are data driven rather than the guesswork from a particular person. That reduce the wastage and then improve the efficiency. We can also use the predictive maintenance for the energy efficiency. AI and machine learning models analyze the vibrations, temperatures, sound, pressure data to predict when any kind of equipment or the component of the machines will require any kind of maintenance over there. Then this prevent the any particular part of the machine from operating in the low efficiency state that consume the excess of the energy. Predictive maintenance reduce unexpected breakdown is then which can cause high energy spikes when machine attempt to compensate. Also, the load balancing and the peak demand reductions. So, Industry 4.0 energy management systems automatically shift the non-critical loads, such as we can say the charging, heating, auxiliary processes. So, to time when energy demand and then the tariff are lower. So, AI-based load forecasting ensure that total energy demand stays balanced throughout the day and prevent the peak and the load from the utilities, you can say companies. Smart grid and integrate the battery energy storage systems, that is known as BESS, that is allowing the excess of the energy to be stored during the low demand of the period and released during the peak hours. Load balancing help industries to achieve cost saving, we can also say the operational stability, and for the better alignment with the renewable energy sources. So how to implement Industry 4.0 energy management? So this is the main thing. So the step one is to install the IoT enabled smart sensors in our companies. So this particular foundations of an Industry 4.0 energy management system for the data collections. So traditional energy monitoring often lack of the these particular things to precise the optimizations. So IoT enabled smart sensors meters. So bridge this particular gap to provide the real time data on energy usage at the machine level. So collect energy data from the machines, then lighting, then we are having different type of systems and deploy these sensors on individual pieces as well of the any part of the machines. Assembly lines and different building infrastructure like where we are having the heating, ventilations, air conditioning are there. So this particular data are collected firstly, including the electricity consumption, temperatures, humidity. So basically these are related to companies or manufacturing plants. So we have to discuss these uh, to check the machine status. So these IoT systems monitor the usage of the usage trends and is there any inefficiency are there, then detect the inefficiency. So this process continuous stream of data is set to the centralized platform that allow the facility of the manager to check this data. And we have to check the energy performance, then monitor the any usage patterns throughout the day. With this particular thing, we can also identify the any kind of anomalies there quickly, rather in case of the in traditional method. So any energy leakage are there, underperforming equipment of the machines. So we can check with the help of the IoT systems. The second step is about the use of the AI and the automation for the optimizations. So once data is flowing, AI and the automation turns this data into the actionable intelligence and the real world saving. So AI algorithms analyze the vast data set and a huge amount of data. So we have the AI-driven analytics suggest the real-time energy-saving actions. The analytics performs, you can say, the machine learning to recommend the specific optimizations such as ideal operating times for the machinery. We have the predictive maintenance schedule, energy intensive assets, and the power factor corrections kind of things. So we can also automation systems that you know adjust the settings. You can say to minimize the waste. So these systems can automatically implement these recommendations. For example, AI might maybe automatically dim the lighting in the unoccupied areas of the company. Then we also the real-time weather forecast schedules on the non-critical processes during the off-peak energy pricing hours to minimize the cost. Step 3 is about the integrate with the renewable energy sources. So to enhance the sustainability and the resilience, the intelligent energy management system integrate with the on-site renewable energy generation and the storage one. So here AI can manage the solar, wind, battery storage for the optimized usage. So AI platform predict the renewable energy output, like how solar power will be generated on a sunny day and the electric demands. So, in case of the businesses gain the energy independence and the sustainability, so this particular strategic management reduce the resilience on the public grid, minimize the exposure to volatile energies prices. We have the facility of the carbon footprint and move these businesses toward the greater energy independence. This is about the energy efficiency in Industry 4.0. We have some of the key elements of the energy efficiency in Industry 4.0. So connected sensors monitor the energy used continuously, like IoT sensors are installed on the machines, motors, and the production lines. These sensors record the metrics such as voltage, current, temperatures, vibrations, and then the operating hours. Continuous monitoring helps identify the machines that consume the excess of the energy due to the inefficiency or any kind of fault are there. So we need to the real-time visibility that allow the corrective actions, not only corrective but in a quick manner. So reduce the unplanned energy wastage are there. The second one is the real-time data analysis drive smart efficiency. This data collected by the sensors is processed instantly by the use of AI and then the latest technology. So AI detect the patterns, any anomalies are there, peak loads, hidden inefficiency that human may miss in case of the traditional companies, traditional manufacturing system. So real-time analytics help industry optimize the energy consumptions per unit output. Centralized control optimization, energy consumptions. So centralized systems manage all machines, processes, and energy consuming devices. In case of the predictive maintenance, prevent the costly downtime. So AI powered predictive maintenance uses the sensor data to forecast when machines will fail. Maintenance is performed at the right time before any breakdown occurs. Sorry. So this avoid the sudden time of shutdown that create the huge energy spike. Sorry. So we have the process visualization aids that the energy saving designs are there. So in case of engineers use with digital twins, visualization simulations to study the energy flow. In production lines, the inefficient steps are there, then bottleneck also problem there. high energy zones are there, then identified during the visual testing. The waste heat recovery reduces the overall energy wastage. Many industrial processes release the unused heat during the production. The automated reporting tracks efficiency progress. So the automated energy reports summarize the usage, any peak loads, efficiency level, and improvement areas is there. So in case of the energy efficiency in India, we are having three, four country profiles. So India finally, regarding this, India finally energy consumptions increased by 50% by from 2007 to 2017. So with the growth across all the sectors, but with the largest increasing in case of the industrial and the transport sectors. So it has been the highest growth of the primary energy amongst G20 countries, but still has the lowest GDP as per capita. So improvement required here in case of the energy efficiency. So due to the growth of the Indian economy, energy use has continued to increase. Structured, you can say the different type of sectors such as movement toward the energy intensive transport mode. We are having the increased appliances ownership, and then the building floor area also added to the increased energy usage from, you can say, between 2010 to 18. Fortunately, energy efficiency improved in India since 2010, preventing 12% of the additional energy usage in 2018. So between 2018, we are talking about the 14 to 18, then energy efficiency were mainly achieved in case of the industrial sector. So these gains were not only the 5 times the efficiency gain in the transport and then building over the same time, especially in case of the 2018, 24.5% of the Indian total energy use was covered by the mandatory energy efficiency policies. So the main contributor being to perform, achieve, and the trade. That is known as the PAT scheme. That is known as the perform, achieve, and the trade. So the key policies driving the efficiency gain in the industrial sector. Energy efficiency, we are having, talking about the opportunities, then the adoption of the appliances standards, building codes in the some of the states, coupled with the growing energy access and the new consumption, resulted in policy coverage in the building sector by 13% in case of the in year 2018. So in case of the transport sector, the implementation of the passengers car, and we are also talking about the heavy vehicles, policy coverage to 6% in case of the 2018 year. So under the efficient world scenario, the increase in the energy demand could be the limited to just 82, not only 82% between now and in case of 2040. So as opposed to the double in case of the NPS system. So this would avoid the 10 EJ of the additional energy usage. So we have to mainly, saving would mainly come from the industry 45% and the building 30% followed by the transport sector. This particular slides related to the decompositions of the energy usage in India between 2010 to 14 and 14 to 18. So this particular chart break down how different factors contributed to the changes in India total energy usage over the two periods like 2010 to 14 and 14 to 18. So it basically separates the impact into three main key drivers are there, like activity effects, structure effect, and the technical efficiency effect. So we're talking about the first period, that is from the 10 to 14. So what changed in this period? So activity, in case of activities that increased energy demand. So this particular activity bar shows that the large positive increase, indicating the greater industrial activities, economic growth, and a higher demand for the energies. So this is the biggest contributor to rise the energy usage in 2010 to 14. Then second one is the structural effect, that is small increase, and the structure bar is small one but positive one. So this means that Indian economic structure shifted toward the more energy intensive sectors such as manufacturing and the heavy industries. If you're talking about the 10 to 14, the technical efficiencies effect that decreases, but the technical efficiencies bar is negative. This showing the energy savings due to the better technologies. Industrials now adopted more efficient equipment, reducing the overall energy usage. So saving not enough to offset, but in case of an energy demand. So if you talk about the net result of the 2010 to 14 period, then total energy usage increased mainly due to the higher industrial and then economic activities. The second period about the 14 to 18. So in this period, what changed? So in case of the activity effects, very large increase. So again, activity was shows a major increase even larger than the previous period from the 10 to 14. In case of the structural effect, that is a moderate one, moderate increase. This structure bar is still increases, but India continue to shift from energy intensive sector, further raising from the energy demand. The last one is in this case the technical efficiency effect, that is larger decreases. So this shows the major improvement in case of the energy efficiency, like we have to use energy efficiency, industrial processes, LED transitions, and improved power plant efficiencies, energy conservation program out there in India. So based on these three bar, we can say that energy use still increased, but energy efficiency offset is a larger portion of the increase as compared to the previous period, that is 10 to 14 one. So the next picture is about the overall energy efficiency in case of industry 4.0, the saving from the energy efficiency in India 14 to 18. So this particular chart is highlight how energy India saved between 2020 14 to 18. So due to the improvement in case of the energy efficiency across all the industries, household, transportations, power generations. So the major energy saving is a larger bar, that is a tallest bar, that is 1.3 AJ, exageras of the energy saved. So this represents the major contribution of the energy improvement across India. So we have to talk about the how India save energy. So saving energy come from industrial efficiency upgrades, adoption of the energy efficiency in case of different type of machine equipment, power plant efficiency improvement, LED and the different type of appliances program are there. So better building and the different control systems. The second moderate savings, medium bar, indicate the medium level of the energy saving. These savings likely came from the small and the medium industries adopting the efficient technologies. Better energy management practices are there. We can also have the upgraded motors, pumps, compressors, and we are having the transport modes more efficiently used in case of this particular thing. Then third one is a smaller one, the smaller bar. This indicate the lowest one. The still we have some meaningful saving out there. So residential LED adoption is also a key contributor here. They also efficient household appliances, different appliances we are using in household. Micro level behavior changes, turning off the devices, using efficient lighting, and the awareness of different government programs. So energy efficiency measures there in 2014 to 18 generated substantial savings, reduce the need of the additional energy generations, and the largest saving came from the uh, you can say improvement in industries and the power sector, which have the most energy intensive operations. Smaller but the meaningful saving from residentials and the smaller industry activities. We can have different policies out there from India. So India avoiding a significant amount of energy consumption due to better technologies, efficiency in case of different implementation of the policies. So such as Ujala LED is one of the programs here. PAT schemes, efficient motors, and improvement in case of the grid operations. The next picture is about the energy efficiency in industries 4.0, that is mandatory energy efficiency policies in case of India 2010 to 18. So this particular chart is about compare how much the India's total energy use covered in case of the mandatory energy efficiency policies in four major sectors like total building, industry, and the transport one. So between 10 to 18, that compare these values with the global average. So the total values, the total energy covered in the mandatory policies 2010 in India, very low. Less than 1% of the total energy use was covered by the mandatory efficiency policies, indicate the early stage adoption of the energy regulations. In India, 2018, approximately 25 to 27%, a major improvement out there. So policies are expanded across industries, tax scheme, appliances, standards are there. In 2010, if you're talking about the global, then about 20%. So global policies were far ahead of the India in 2010. In 18, around 35% in global, that was that is strengthened its efficiency regulations over the decades. In case of the building sector, so the second one is, so in India, 2010, 1 to 2%, that is the minimal regulations covering the buildings energy codes. 18 in case of India, then 12 to 14%, that is the energy conservations building codes update the mandatory appliances, smart building initiatives under Industry 4.0. If we're talking about the global, then in case of 2010, around 20%. In 2018, that is 35%. Interpretation about this global value, the India is progressive one, but building efficiency policy still lag somewhere in case of the global average. The third one is about the industry sector, that is in case of India, in 2010, that is very high, 45%. So India had strong early industry focused policies. So mostly due to the perform, achieve and trade PAT scheme. In case of 18, 35 to 37%. So although still high, but percentage you can say slightly reduced because of energy usage uh, grew faster with the policy coverage, and new industrial segments are there expanded without immediate regulations. As if you're talking about the global compared to India, then 20% in 10 and in 18 around 30%. The last one is about the transport sector. So in case of India, 2010, around 1%, which is very limited policies, mostly fuel standards, some vehicles norms are there. In 18, 67% improvement due to strict vehicles fuel efficiency norms are there, and smart mobility initiatives push to the EV electric vehicles are there, and Bharat stage emissions reforms are there in case of 18, 67% growth. We are talking about the compare this with the global, then 15 to 18% in 18, 10 in 18, 25 to 28%. So how AI can help in energy efficiency? So we have to talk about this point. So AI can help with the optimize complex energy systems. So the energy system is complex, and evolving. So it is becoming increasingly electrified, digitized, and connected systems that is also decentralized. So with the mounting cost pressure, these drivers have encouraged the energy companies to deploy applications from the traditional to the utilize AI to optimize different type of systems, improve the productions. So basically, with this thing, we reduce the cost, efficiency raise, improve the uptimes. We also cut the emissions and enhance the safety of the different component of the machines. So many of the desired goals of the AI applications in the energy sector, such as cost reduction, enhance the reliability. We can also improve the resilience challenging to the quantify at a broader sector levels beyond the confines to the industries, case industries. So AI also optimize the energy systems. Oil and gas companies have among the earlier adopter of the new technologies to boost their this kind of explorations and the productions. So in case if talking about the 2010, then only 11 supercomputers operated by the oil and the other gas companies ranked among the world 500 fastest one. By 2024, these numbers had increased to 24 and total computing capacity has grown to 70% annually. So outputting the broader supercomputing industry. So AI has various uh, application in this sector, including for surface data promotion. Then we have simulations, remote operations out there, regulatory compliances, leak detection. We can also check, repair the automations. So AI has various application in the electricity system always. So owing to the complexity of the supply chain systems, transmissions of the AI in power plants operations. So cost saving up to USD 110 billions annually by 2035 by avoiding the fuel and the lower cost. So AI also help the greater integration with the renewable electricity into the grid. So our analysis find that 175 GW of the additional transmission capacity could be unlocked by existing lines with the use of the new latest technologies like AI and the integration of the AI with the cloud and the different latest one. And in this particular slides showing the applications of the AI and end use sectors are varied but have the significant potentials. So in industry, AI being the used in various ways to optimize the case of the production processes, widespread energy savings up to 8% could be achieved by 2035 in light of the industries such as manufacturing of the electronics and the machinery. So what's the role of AI here? So AI in transport, the enhanced vehicles operations management, which could reduce the energy consumptions. It also has applications in reducing the and different type of anomalies. Also, we are using the electrical vehicles as we have, you can say, widespread range of the electrical vehicles in current scenario. In building, we were talking about, then potential is limited by the rate of the digitizations. So sustainability, what is the meaning of sustainability in Industry 4.0? So sustainability in Industry 4.0 for the integration of the digital technologies that help to reduce the waste, improve the efficiency, and shift uh, toward the cleaner and the more responsible production system. So smart technologies like IoT, robotics, cloud computing, intelligent manufacturing environment. So where the resources used optimal and the environmental impact is minimized. So through the continuous monitoring and the automation systems, industries can now significantly lower the energy consumptions. If you are talking about the emissions, then it reduces the emissions. If we are talking about the wastage, then it reduce the wastage and reduce the materials that use in the lower heavy breakdowns. We can use the digital twins, different type of simulation processes that allows companies to redesign the production workflow to become more eco-friendly before implementing change physically. So before implementing the change physically, we can also use these AI technologies. In Industry 4.0, that's for the circular economy practices by helping the organizations reuse materials, track the product lifecycle data, design products generate less amount of wastage. So with real time data, now company can adopt more sustainable decision makings. With this, we can balance the productivity and the environmental responsibility. Ultimately, Industry 4.0 enables the industry to transition from the traditional linear model to the modern sustainable production model that conserves the resources, carbon footprint reducing, and we can support the long-term environmental goal. This is very important point of view. This is, you can say, not only part of the manufacturing or the industry 4.0, but in case of educational institute, SDG is very important keywords. We are having different keywords, 17 keywords in case of the sustainable development goal. So our target is also when we writing the research papers. So our target is also there from the institute, from the from Indian government that we have to cover different type of SDG in our research work. So how Industry 4.0 for the sustainable development goals SDGs. So Industry 4.0 represent the integration of the advanced digital technologies like IoT, big data, cloud computing. So in case of this technology, not only boost the productivity and the automation, but also play a significant role in the achieving the United Nations Sustainable Development Goals (SDG). So by enhancing the efficiency, enable smarter resources usage, promoting the eco-friendly practices, Industry 4.0 not only directly contribute to a more sustainable and the equitable, you can say the more safer future. So Industry 4.0, how we can have the IoT, big data, going deeper into these technologies because we already discussed these technologies. And what about the industries 4.0 help to achieve these SDG keywords? So in case of if we particularly talking about the SDG 7, that is about the affordable and clean energy. So smart energy grid, sensors, and the analytics optimize the energy use and the integrate the renewable sources. If we're talking about particularly SDG 9, that is about the industry innovations and infrastructure. So Industry 4.0 is the backbone of the modern industries innovations and sustainable infrastructure. Talking about the 11, then sustainable cities and communities. Then it is about the IoT powered smart cities that improve the energy, water management, traffic and the pollutions monitoring. In case of energy SDG 12, that is responsible consumption and the productions. So automations, digital twins are part of this SDG 12. In case of the climate action, that is SDG 13. This is about the real-time emissions monitoring systems, energy efficiency tools, predictive analytics systems. SDG 8 is about the decent work and the economic growth. So robots, AI, automations, these are the you know technologies that are part of the SDG 8. Again, in details, these SDG how this is interrelated with the Industry 4.0 technologies. So this is very lengthy slides. So basically, in case of Industry 4.0 technologies, IoT, if we're talking about IoT, then it relates with SDG 7, that is clean energy, SDG 9, that is industries and the innovations, SDG 11, that is sustainable cities, and we are having same scenario with the big data analytics, cloud computing, cyber security, horizontal and verticals, integration, robotics. The last one is a simulation that is related with the SDG 13 about the climate actions, SDG 7 that is about the energy efficiencies, and SDG 12 that is about the sustainable productions. So this video is about the AI for energy efficiency and sustainability in Industry 4.0. The current slide is about the AI for energy efficiency and sustainability. So how we transform normal industry to the smart industries. So we have to cut energy cost and the predictive with the help of the predictive AI. So rising energy costs significantly affect the profit in industries. So we have to use the AI-driven predictive models that help company to analyze the real-time and energy consumption patterns are there. So we have to identify the is there any inefficiency are there. Then on the basis of this, we have to forecast the future energy need. So by automatically adjust the machine's operations, then we can also optimize the production schedules and reduce the unnecessary usage of the machines. So using the predictive AI help industries to minimize this energy wastage. Avoid the downtime with the predictive care. So unexpected equipment failures are one of the main loading causes of the, you can say, the in case of the energy loss and production delay. So we can use a predictive maintenance usage in case of the machine learning sensor data to detect the early sign of the malfunctions. In case of the abnormal vibrations out there of the machines, if any kind of the temperature spikes are there or the irregular, you can say the load patterns are there. So by predicting the failure, uh, is there any kind of failure occurs, then industries can perform timely maintenance, prevent the breakdowns, to reduce the downtime. So we have to boost the sustainability with the AI. Sustainability is today's requires the precise monitoring of the emissions, energy consumptions, and we have to also renewable energy sources. So AI play a central role for, you can say, the accurate forecasting and identify the emissions, and the hotspot is there, optimize how industries use natural resources. We can also use the digital twins to simulate real world energy systems. So these can help the energies design greener as well as more sustainable approaches. So how AI enable this? Because the main target is about the AI role in case of the sustainability. So how AI we can use? So real-time energy monitoring and the optimizations. So AI analyze the real-time energies consumptions across the machines, lines, utilities. Identify is there any kind of inefficient equipment are there, energy leakage, adjust the machine settings, speed, load, and kind of temperatures. We can shift the load operations. In case of the second point, that is the predictive maintenance for the energy intensive equipment. So AI predict the equipment failures before they occur using the vibrations, temperatures, current data. Prevent the sudden kind of breakdowns are there. So with this we can have the energy wastage, but during the restart of the emergencies operations. And third point is about the process optimization, so the intelligence control. So we have to use the AI fine tunes processes. So we can use the machine learnings and the model predictive controls, that is the MPC. So with this we help to reduce the overheatings, overcoolings, and unnecessary running systems. Now integrating with and optimizing the renewable energy, AI forecast the solar, wind energies, hydropowers availabilities with the high accuracies. We can accordingly schedule the high energies processes during the period of the high renewables generations. Balance renewable and the grid energy to minimize the carbon footprints and the energy cost. If we're talking about the digital twins role, then for the sustainable decisions making, we can create the virtual replicas of the machines, production lines, and the entire plant as well. So simulate the energy usage, material flow, environmental impact before the implementations. We can also test multiple scenarios like design changes, new processes, machines upgrades without physical risk. So this can help the industries to choose a more efficient. and the low carbon strategy. If we're talking about the AI-based quality control reducing that waste, so we can use computer vision's pattern recognition to detect the defect in real time. We can reduce the scrap work, rework material wastage to save the energy spent reprocessing activities. Not only the 6 point we are having 12, how AI enable this. We can also use the smart supply chains and logistics optimizations. So predict the demand accurately, reduce the overproductions and the inventory wastage. We can also enhance the warehouse automation system and energy efficiency systems. We can also minimize the carbon footprint across the entire value chains. AI-driven emissions monitoring and compliance, automated tracking of the CO2, methanes, and other greenhouse gas emissions. Predict the future emissions trend to for the regulatory compliance with the India as well as from the different countries. Workforce augmentations and safety. So AI-powered automations reduce the human exposures to hazards and dangerous conditions are there, uh, high energy environments. So we have safer working conditions, low energy usage of the reduced downtime. We can also use the smart buildings to facilitate the energy management. So using this, we have to adjust the temperatures, airflow dynamically based on the occupancy and the production load, reduce the overall facility energy consumption significantly. We can also use the circular economies and the energy efficiencies of the resources. So AI improve the recycling, waste sorting, and the reuse of the materials. Optimize the water treatment and the reuse systems. Track the materials flow to reduce the raw material consumptions and environmental impact. We have to plan the strategic planning and the long-term sustainable insights like using the SDGs and help industry to make the informed decision about the green technologies and the energy investments. This is about the smart factories. So how in case of the smart factory, AI enables greener, learner and manufacturing. So AI powered dynamic schedulings allow factories to optimize when and how machines operate instead of running equipment at a fixed time. So AI technologies analyze the real-time demands, energy prices, production load, and machines performance. We can also use a predictive maintenance. In case of predictive maintenance, use the machines learning sensor data to identify early signs of the equipment failures, such as you can say unusual vibrations, temperatures, any fluctuations, power supply also irregular in case of companies. So by predicting these faults before they occur, AI help industry to avoid the major breakdown that lead to the costly repairs, productions stoppage, energy wastage. We can also use the supply chain optimizations. So AI play a critical role in optimizing the supply chain processes end to end. It reduces CO2 emissions by determining the most efficient transport routes, optimize the warehouse operations, and improve the logistics plannings. So we have to balance the AI energies footprint with the sustainability. So what about the challenges? So AI technologies, especially large-scale models, automation systems, and the data-driven analytics requires massive computational power. So this lead to the high energy consumptions in data centers, GPUs, cloud infrastructures. So as AI adoption accelerate worldwide, so energy demand from data center is projected to around 18 to 20% annually by 2030. In case of industry response, to address the challenge, industries must focus on AI, making of the AI operational more efficiently. This includes optimizing the AI algorithms, using the energy aware training techniques, switching data center to the renewable energy sources, deploying the AI models to the energy efficiency hardware. In case of the innovative part, we have to, in case of future direction, we have to focus on making AI not only powerful, but also the sustainable one. So major area in futures, we have include the explainable AI that is known as XAI, which makes AI model simpler, more transparent, and less computational intensive. We can also use in future energy efficiency AI algorithms that is design and deliver high accuracy with a minimal power usage. We can have the greener AI metric, which measures energy and the carbon cost of the training and the running AI systems. We can also the AI driven optimizations, where AI itself help reduce the cost and the energy usage of the data centers. So if we're talking about the global leaders, in case of the current context of the sustainability and energy efficiency, so global leader and initiative, different initiatives of the different countries, driven the AI for energy efficiency and sustainability. So key global leaders are and the initiative driving the adoption of the AI for energy efficiency and sustainability industries. Transportation include the major technology corporations have different type of companies. International collaborations platforms are there. So leading tech companies such as Google, Microsoft, IBM, Amazon, Siemens are developing the AI to reduce the data centers emission, improve the industrial automations, and enhance the energy management through the predictive analytics, digital twins. Now companies like Shell, BP, and Electric and General Electrics are just using the AI optimization. In addition to these initiatives, international energy agencies, that is the IEA, global partnership with the AI, that is GPI, and we are having missions, innovation, and World Economic Forum, that is the WEF, clean energy and industry platforms that play crucial role in promoting the collaborative research, policy guidelines, and we, we have to use the best practices. Now, different global leaders like Google, the pioneer of the advancing 24/7 carbon-free energy solutions, so achieving up to around 40% reduction in cooling cost in its data centers. Microsoft AI for Earth program initiative by the Microsoft. IBM Environmental Intelligence Suite offers, that is AI-powered platform for monitoring and forecasting the climate impact. Engines, that is electrical, Siemens, that is the General Electric, GE. So these industries and that the energy giants apply the AI for smart grid management. Tesla integrate the AI into electrical vehicles, energy storage, that is powerful and power pack to optimize the energy consumptions. Unilever's, Walmart, and these type of companies using the AI in their supply chain optimizations, route optimization in logistics, demand forecastings to reduce the waste and the carbon emissions in their operations. So they are the the global leaders, different companies. Apart from these, we are having also the key individuals like Dr. Sultan Ahmed Al Jaber, that is the CEO of the Adno companies. He is the champions of integration of the AI with the renewable energy to meet the future's demands. Emphasizing on the collaborations and the significant investment in the low carbon projects. That is the Mahmoud. One is one of the other persons that use the productive solutions of the AI energy. Then the Kate Bryant is also the Google Chief Sustainability Officers, and she oversees the strategies for using the AI for optimizing resource allocations. Apart from these, we are having the different type of global initiatives and collaborative effort like UN AI for the Good initiatives, with the AI 24/7 carbon-free energy coalitions. We are having also the public-private partnership. Now, India, if we are talking about just in India only, our country, that is India, stands at the pivotal role and moment at the development journey and mounting pressure to meet the global targets. Our country is rapidly scaling up the effort of the renewable energies investment, sustainable finance, and green growth. So Niti Aayog, India, the premier one policy thinkers, map 100 of the government inventions to the United Nations in India's Sustainable Development Goal, that is SDGs. So at the same stage, India has hold climate, that is about the sources by 2017. So 50% of the energy from the renewables by 2030, and the create 2.523 billion tons CO2 sink, while the additional forest and the tree cover by the 2030. There are different type of schemes are there, that is totally based on these initiatives like Jawaharlal Nehru National Solar Missions, so launched in January 2010 under the National Action Plan on Climate Change, that is NAPCC. Solar mission set out the positions of India as a global leader in the solar energy. There are in Pradhan Mantri Kisan, that is a Pradhan Mantri Kisan Urja, that is Suraksha, and different type of PM Kusum Yojana, launched in 2019, that is PM Kusum, aims to solarize the agriculture sector, major energies consumption segment in rural area. So this particular scheme has three components: smart grid connected with the solar plants up to 2 megawatts, and the installation of the standalone grid solar agriculture pumps, and solarization of the existing grid. So as of August 2023, about 2.46 lakh farmers had benefited from this particular scheme. So why this particular thing is matter? Because PM Kusum links sustainable finance, renewable energies investment, and the rural development. So by reducing the diesel pumps use and the providing solar systems, so it lower the operational cost of the farmers and improve the energy security. The next one is the National Bioenergy Programs under the MNRE. The National Bioenergy Programs promote the biomass, biogas, and the waste to energy solutions.
Professor
So
Rajendra,
while the,
am I audible, Professor Rajendra?
yes, sir, audible,
Kindly
sir.
conclude, please. Na? Next session will also followed by your session.
Okay, sir, okay. Last, sir, 5 to 10 minutes, sir.
Okay.
So this slide is about the global leaders again. So we are having different type of things we have to fulfill to achieve sustainable and energy efficiency. So we are having national mission on the sustainable habitat, that is the NMS subject. That is this particular launch under the National Action Plan on Climate Change seeks to make the Indian cities more resource efficient, cleaner, and climate resilient. The National Green Hydrogen Missions purchase the obligation, that is the GHPA, building upon the broader green hydrogen missions, green hydrogen purchase obligations, that is a forthcoming policies mechanism expected to mandate that certain industries, particularly steel, fertilizers, refining the purchase of a fixed share of the green hydrogen in case of the total hydrogen use. Energy audit and the implementation scheme, that is the Bureau of the Energy Efficiency BEE. Energy audit from the backbone of the Indian energy efficiency strategy. So the energy audit and the implementation schemes implemented by the Bureau of Energy Efficiency aim to identify the and rectify is there any efficiencies in industries operations, public infrastructure, and the commercial buildings. Then green business scheme is about the green entrepreneurship and the circular economies innovations. The solar power plant on the government buildings, apex mode. This is about the government to promote the rooftops solar installations on the central and the state government buildings. Now, this is about the AI sustainable practices. Again, the related global. Now we conclude with the some of the what are the features of the AI for energy efficiency and the sustainability in industry, especially in industry 4.0. So AI-powered net zero factories, automations, and self-healing industry systems, hyper-personalized production with a minimal wastage. We can also use the AI-driven energy markets and the smart cities integrations. We can also use the climate forecast and the driven industrial plannings, innovation of the brain AI, and a stronger global and the collaborations with the regulations used of the India as well as from the different countries' point of view. Okay, sir. That's from my side. Is there any question, sir?
Any question regarding the session, participants?
Yes, sir. I have one question.
Yeah, please.
Sir, as per current industry scenario, the giant company and like a large company, they are easily adopting this digital transformation. They are ready to integrate their devices and adopting this industry 4.0. But the small and mid-scale company are facing the financial issue. They have to integrate their sensor and machine with a field gateway server, and then migration of data into cloud, and then from the cloud. They have to use a data pipeline, and they also have to invest more money in a data scientist and data engineer to generate a model and get the insight from this. So this is the big issue from this kind of company. So how academia can fulfill this kind of gap? This is my question.
So this is actually vary from country to country, but in case of different country, we can't predict this scenario because we have to count the global scenario in that scenario. But in that case, but in case of India, India is very initiative in the context of different type of policies implemented in educational field and as well as in case of the manufacturing. I have discussed already, different type of initiative laws from the central government to different states and providing not only to the big companies, but we have smaller, if we are having some smaller kind of companies, then Indian government providing different type of financial to them. Because AI now play transformative and the multi-dimensional role in case of improving the energy efficiency in case of and sustainability across modern industries. So whether we talk about the smart factories, renewable energies integrations, predictive maintenance, digital twins, sustainable supply chains, AI provide a scientific and data-driven foundations for better decision making, not only for the bigger, you can say bigger manufacturer, but the smaller kind of. So it is totally dependent on the country to country. But in case of India, India is very you can say smoothly going in a positive direction.
Okay, sir. And last question. And here, one slide that you are mentioning digital twins. So this word is coming across many times. So can you explain what is the meaning of digital twin technology?
Actually, sir, if we are implementing different type of policies or different type of processes on the real machines, then it is very difficult to stop that particular machine and enhance and check the machine. But using the replica of these machines, these processes, and even in a total companies, we can also create replicas. So on the replica, we, we implement these things. Then it's very easy for us to analyze the things. For example, if we can also use the simulations kind of things. So in case
Okay.
of real scenario, it is very difficult for a person. Uh, but in case of simulations, we are having simulation available, and we have the replica of the processes of the company of the different type of machines. Then it is easy for us to analyze the things.
Mhm.
Sir, I have a question, sir. Can I ask,
Yes, yes.
Yeah, please.
sir?
Yes,
Sir,
yes.
sir, my question is there any AI techniques which are used for energy optimization in manufacturing systems, sir?
Here multiple techniques are there. So AI technique used for energy optimization in manufacturing range from basic machine learning to advanced reinforcement learning neural networks are there. So if we are talking about the machine learning especially, then motor consuming the excess current, AVAC system are there efficiently, that is efficiently operating machine learning under the partial load. So in case that we use the machine learning, if we are talking about the deep learning, then in case of CNC, RNN, we can use deep learning. If we are talking about the reinforcement learning, that is the RL, then optimize the robot paths, control the heating, cooling cycles, manage the multiple machines scheduling. We can reduce the peak load energy consumption with this. Evolutionary algorithms are there, swarm intelligence are there for minimize energies, throughput, quality of the product. We can use the fuzzy logic for HVAC systems, temperature control systems, and we can also complex kind of chemical processes are there. We can again the digital twins also integrate with the AI integrations to real-time energy monitoring systems. Where are the scenario-based optimizations? We can create the virtual testing of the new layout of the or machines configurations. So I think with this we can use new technology. Any others? Parvan?
Yes, sir.
Sir,
One,
good evening.
hello.
Good evening, sir.
Good evening,
Sir,
sir.
one question I have, sir.
Sir.
One question. Any, sir,
Hello.
hello. Hello.
Hello.
Yes, sir. I am
Hello.
good.
Sir, I have one small doubt, sir.
Yes, sir.
Hello.
Yes, ma'am.
Hello.
Sir,
Sir,
any challenge that limits AI adoption for energy sustainability in Industry 4.0?
So major challenges include a high cost of the digital infrastructures, data privacy issues are there, lack of standardizations are there, and across the industrial protocols. So this limit the availability of the skilled manpower. So many legacy machines lack in case of the IoT connectivity, making data capture difficulty. So cyber security is a major risk.
Okay, sir. Thank you, sir.
hello.
Hello. Good evening, sir.
Integrating
Hello.
with the systems,
Hello.
this of the energy systems.
Uh,
Hello,
Hello. Good evening, sir.
good evening. Ji.
Sir, can you please tell about what is the basic role of digital twins if we are talking about the improving in energy efficiency for Industry 4.0?
Actually, digital twins create a virtual replica of the machines, production lines, or you can say the factory. So digital twin continuously receive the live sensor data, and then you can have the reflecting real-time operations solutions. So they allow the engineer to visualize energy flows, detect any inefficiency out there, then test the optimization system strategy without disturbing the actual operations. So in case we are talking about some of the example of this, the digital twin is the finance of uh, the simulations we can also have there. So AI-powered teams analyze thousands of the simulation scenarios in seconds, identify optimal settings that minimize energy consumptions. So digital twin not only support the long-term planning while predicting the how energy usage will evolve with the changes in demand. We can also implement aging and environmental factors. So these particular things help the industries to detect the inefficiencies such as air, air thermal losses, vibrations, inefficiency, or any kind of power quality issues are there. So with this, we can use the digital in improving the energy efficiencies in Industry 4.0.
Hello.
Okay, sir. Thank you. Thank you, sir.
Hello.
Yes, ma'am.
Sir, I have small doubt, sir. With this industry 4.0, shall we mitigate the air pollutants that are beyond the AQI levels? Shall we mitigate with the help of AI, sir?
Ma'am, it
Since
is
nowadays air pollution is very much high in some cities, shall
totally
we mitigate that, sir, by using air industry 4.0?
ma'am, totally depending on the how different type of policies from the governments, central government we implemented on the state or the local governing bodies. So how we are serious about the environmental. So not only AI fundamentally shaping how industries manage energies, so also optimize the different type of operations. We also achieve different type of sustainability target. So by combining not only ma'am, this thing, we also because we also combine the IoT data, advanced analytics, machine learning. So not only AI help in this scenario, the industries make smarter decisions at every stage, from the production line to the equipment. But in this scenario also, we implement the government things and at the state level, then we can solve this problem.
Okay, sir. Thank you, sir. Thank you, sir.
Good evening, sir.
Hello,
Hello.
hello, Anjali.
Yes, sir. Sir, actually, I'm planning to do my research work in multivariant process control, especially in oil industry. So, in that, how can I implement this machine learning and digital twin, sir?
If you're talking about research topic, then it's digital twin, and we can use the data-driven optimization for smart factories. Like we have to build the closed-loop digital twins that simulate the factory energy flows and run online optimizations. So in this scenario, we can use a model like predictive control, differential simulators are there to reduce the consumptions of the different type of energy.
Sir, it is possible to integrate machine learning and PLC systems, sir?
Yes, ma'am. Different type of research area are there possible. If we check that, federated and privacy preserving learning also for the decentralized energy management also possible. If we are talking about the edge AI, then that is also possible for the real-time energy control on factory floors. We can also use my latest topic, that is the green AI. We can use green AI for energy-aware model to design and the life cycle analysis. We can also informant learning and also use for scheduling, demand response, energy markets. So we can also use AI for, you can say, the microgrid, virtual power plants. We can also use explainable, also one of the latest one, explainable and the trustworthy AI for the energy decisions. So lots of area out there that in, but but mainly point is that we have to integrate AI with the different type of technologies to get the accurate result.
Okay, okay, sir. Thank you, sir.
You are not audible, sir. Arvind sir. Arvind sir, you are not audible. Your mic is muted.
Yeah. Dr. Rajendra sir, your session on the topic
Again, here you are muted, sir.
was very informative, highlighting
Sir, you are not audible. Arvind sir, Dr. Arvind, please. You are not audible. Kindly unmute your mic.
hello. Is it?
Yes, sir.
Audible, sir? Sir, your
Yes, sir.
session was informative, sir. Thank you so much, sir.
Thank you, sir, for inviting me for this beautiful FDP, sir. Thank you very much, sir.
Okay. So,
We will start the session at
yes,
7:55, sir.
7:55. Yes,
Yes.
we can start 7:55. Yes, after 5 minutes, we will continue to the session.
Thank you, sir.
Okay. Okay, welcome on the second session, Dr. Vineet. Either Dr. H.A. Kihuta join or not? Yes, yes. Welcome, sir. Welcome, Dr. H.S. Hota. Yeah. Dr. H.S. Hota is a professor of computer science in Department of Computer Science and Application and Dean Faculty of Science at Atal Bihari Vajpayee University in Bilaspur, India. Prior to joining Atal Bihari Vajpayee University, he has worked as associate professor at the same university and as assistant professor at Guru Ghasidas Central University, Bilaspur, India. He earned his PhD from Guru Ghasidas Central University in Bilaspur, India. His research interests include artificial intelligence and machine learning, business intelligence, information security, including cloud security, data mining, and evolutionary computing. And he has published over 105 referred journal articles in reputable journals. In conference proceedings, more than 60 articles have been published. He has also won 5 best awards at international conferences. He has also been to several countries uh, and spoken at international conferences as keynote speakers. There are 3 patents related to application of machine learning in different domains in his credit, and published 1 book and 3 edited books are in pipeline from internationally reputed publishers. He is also actively involved in various administrative activities of the university as well as Chhattisgarh State. He is also member of editorial boards of 5 international journals as well as reviewer of many reputed journals of Elsevier and in the science. He is member of many academic bodies including Computer Security of Indian CSI and Indian Science Congress. Welcome, Dr. H.S. Hota, sir. Over to you.
Thank you. Am I audible?
Yes, sir. Audible.
Okay. Thank you once again, Dr. Arvind Devanganji. And I'll continue my talk with the previous talk. And I'll start with the scratch of machine learning. See, as we are talking about AI everywhere, and recently you have heard about AI in energy efficiency, AI in this, AI in that. So let's try to understand what actually means how the AI can be used in different scenario of Industry 4.0. Basically, we talk about AI, but at the core of the AI, machine learning is there. So the actual work is being done by the machine learning. As we have seen in my last session, that AI is like a kind of discipline where we study about the development of a machine, which will work very similar to human being. While machine learning talks about the algorithms, the process of procedure for training any AI model so that it can behave similar to a human being. And if you go inside the machine learning, you can have artificial neural network, which is mimic from the human brain. In our human body, we have a lot of biological neurons, and there is a certain behavior of biological neurons. And similar to that behavior of biological neurons, we can have artificial neuron, and which exhibit similar to the human brain. And nowadays, when we have different kind of heterogeneous kind of data are available, which is being generated by the different devices, different machines in case of Industry 4.0, that can be simulated well in using deep learning. And the 2 variant of the deep learning are CNN and LSTM. So friends, let's try to understand what actually machine learning, and I'll tell you, if you are from non-computer background, I'll tell you the different tools which are available to develop an AI model. So the machine learning is what we are trying to develop a machine which will work very similar to a human being in different scenarios of Industry 4.0. Being a human, we are learning from the experiences. We learn from the environment. We learn from the internet. We learn from the different sources. We gather information from the different sources, and we learn and we improve our knowledge, and hence we become intelligent. And in case of machine learning, the machine learns from the data. Friends, the data is very important when we talk about AI model. If whenever you want to develop any AI model using machine learning, you must have data. So the data which are already available, the historical data which are available, say for example, in Industry 4.0, if you have fault data, machine fault related to machines data are available to you, so that you can have the predictive maintenance, you can have like the fault prediction you can do. So on the basis of some historical data, huge amount of historical data, you need to develop any AI model using different algorithms of machine learning. So similar to the human learns from the experiences and the machine learns from the data. So the data is very important ingredients when we talk about development of any AI model using machine learning technique. There are certain steps involved for developing any machine learning model. As I explained you earlier, and many speakers have already explained all these things, that there are certain style of learning that is known as supervised learning and unsupervised learning. The human, being a human, we also learns in the supervised manner and in unsupervised manner. When the teachers are teaching, a teacher is teaching inside the classroom, and if you are learning something, and that kind of learning environment is known as supervised learning. But when you are learning without any teacher, like if you are learning something uh, through yourself, that is what unsupervised kind of learning. So these two different style of learning can be used uh, for developing any AI model using machine learning technique. So when you have some data available for you, so the data may have some features, and that features are used for training your model. And in case of supervised learning, you can have label data also. Like, see, the target data are available to you, and by feeding the features, input features as well as output features, you can train your model. And once you will feed all the data, and the algorithm will try to adjust the weights of that all artificial neural networks connections. The models will be called learned model. So once the model will be learned, you can check the performance of that model using the various performance measures like accuracy, sensitivity, specificity, and other different kind of measures are available. On the basis of all these measures, you can check whether your AI model or machine learning model is performing well or not. If you are not satisfied with the performance of your trained model or learned model, you can repeat the process, and you can apply the different kind of training algorithms. You can have the different supervised learning algorithm. You can try different kind of supervised learning available, which are available to you. You can have parameter tuning also. You can adjust the parameters so that the performance of your model can be improved. You can improve the data, historical data, which you are going to use for training your model. So there are different ways how we can have the better model, how we can improve the performance of our model. So this is all trial and error method. So ultimately, you have to satisfy that your model is performing well on the basis of some performance measures like accuracy, sensitivity, specificity, and other measures are also there. So once you have satisfied that yes, your model is working well, then you can go for the testing process. So there are basically these are the two-step training process and the testing process. So when we are learning inside the classroom, that is what training process. And then when we appear in the examination, where we are able to solve the question, that is what the testing stage. So in the testing stage, only the input features are there. So you can have one object. From this particular object, the features can be extracted by your algorithms, and the features may be like the color of this object, the size of this object, radius of this object. So there are many other features are there. So that features are extracted, and the learned model will predict whether this particular object is apple or not. So this is a very simple process of machine learning, the two-step process, training as well as testing. It depends upon what style of learning training you are going to use to develop your machine learning model. Friends, there are very important components or ingredients. Just you can say that what are the different ingredients are there when we talk about development of any AI or ML based model. Like in case of industry 4.0, you can have different kind of data and heterogeneous nature of data you can have. Sometimes you can have image data, sometime you may have video data, sometime you may have this audio data. So heterogeneous nature of data can be you can have the data from the industry 4.0 related machines, and these data are very important. And if the data are not in a proper manner, you have to pre-process the data. So in case of machine learning, the data pre-processing is very important step also. In before feeding that data to any machine learning algorithm, you have to purify that data. So the data pre-processing is one very important aspect of any machine learning, and the different algorithms and different steps are there which you need to follow to pre-process your data, so that the pure data can be provided, can be fed to any machine learning algorithm, so that the model can be accurately predict something for which just you are going to develop your machine learning based model. So you can have the time series data also, which is being generated by any machine in a particular interval of time. So the nature of the data may be anything, but the data is very important in case of machine learning. And see, the features are also very important. Like you can have the features of furnace data in industry, like temperature, pressure, air quality, and etc. So there are different kind of features available of the data. So when we talk about machine learning, we can have the data of high dimensionality. So high dimensionality data means what? Where you are having thousands of dimensions, thousands of features are there. So machine learning is not actually used mainly for a small data or low dimensional data. So if you have huge amount of data, millions of data are available for a particular machine learning model development. And if you have high dimensionality data, then machine learning is basically used, and it is very fruitful and very effective. So you need to understand what kind of features are there in a particular data that you are going to use, which you are going to use to develop your machine learning model. So you need to analyze the data size, the sample size of the data, and the dimensionality of the data. You have to analyze what are the different features which are available in that particular data which you are going to use to develop your machine learning model. So in case of data, you need to purify the data, and that is possible with the help of data pre-processing. And features also plays very important role for the prediction in the prediction process. So maybe there are some features which are important, and maybe there are some features which are not important. So that you need to identify which features are very important, which features are not important, or which feature are may play a crucial role in the prediction process, and which features are not actually so important, and the features will not play any role in the prediction process. That you need to identify. And for that also there are several algorithms which are available, and it is known as feature selection techniques. So there is another domain of computer science researcher, that is what feature selection technique and feature extraction techniques. So the data is very important ingredient that you need to understand, and you need to purify the data by using the different algorithms. And the features are very important, and you need to understand what are the features are there, and which features are important and which features are not important. And sometimes you need to extract the features from the available features. Like, see, you can apply some like statistical techniques uh, with two existing features, and you can generate a new feature. So that kind of process is known as feature extraction technique. And sometimes you need to reduce the features, dimensionality of the features, on the basis of importance of that particular feature. And for that also you can apply the different algorithms. And the third ingredients, which are component which are important, which you need to understand as a machine learning model developer, that is algorithms. What kind of algorithms are available for you, and how this algorithm actually works. So for a non-computer people, the algorithm may be a black box. You need not to go through the step-by-step process of a particular algorithm. You need not to understand the inside of the algorithm. Just you can use that particular algorithm as a black box. Okay, so these are the three different components which we need to understand while developing any machine learning model for any kind of problem in case of Industry 4.0. See, when we talk about application of machine learning, there are like, see, two, three kind of applications are there. And this particular application can be used in Industry 4.0 also. Like one is classification. So any machine learning model can classify the different categories of data. See, if in any particular industry, like any product is being produced, so whether that particular product is of good quality or not. So you can segregate this two different categories of products using the machine learning model. So you can develop that machine learning model which can categorize whether the product which is being produced by any industry is of good quality or not. So if it is of good quality, it will be segregated and it will be kept in a particular bucket. And if it is not of good quality, it can be kept in a different bucket. So that kind of classification can be done with the help of machine learning. And for prediction, you can have different kind of prediction. Like, see, you can have the demand forecasting. Means like, see, a particular product means what will be the demand of the particular product in the near future. That can be predicted with the help of machine learning model. Friends, you might be knowing about the various statistical technique for prediction, forecasting. Like suppose stock market forecasting, you can have a statistical technique, but it is in machine learning is established as one of the most powerful technique for any kind of forecasting. So if we compare the machine learning model for any any for forecasting of anything as compared to any statistical technique, then you'll get that you'll find that this machine learning model for forecasting is more powerful than any other technique. So in the industry 4.0 also, we can have the different scenarios where we need to forecast, we need to know the future demand, and in that particular case, we can develop any machine learning model. Okay, and the third application that can be used in industry 4.0, that is counting of product. Like automatically product can be counted, and that process is known as, sometimes it is known as computer vision, machine vision, or object detection. It will automatically detect a particular object, and once the object will be detected, object means what? The product which is being produced by any manufacturing unit, and it will be detected through the computer vision, and automatically the product can be counted. Okay, and it can through the machine vision or computer vision or object detection, the damaged product can also be identified. So these are the different applications which can be used and which are being used, in fact, in industry 4.0. So the core part of AI is what? That is machine learning. You need to develop any machine learning model for your own requirement. So once you have identified the problem of any particular industry that you are going to develop a model for solving this particular problem of your industry, then what you need some data. Okay, you need data. So the data are available in the repository also, and you can have those data to develop your model. You have to understand deeply about the data. You have to go inside the data and the features, and then you decide the algorithm which you are going to use for developing your machine learning model. So these are the scenario where machine learning can be used. So you can escape this one, and I'll tell you the two different kind of scenarios of industry, like hospital industry and agriculture industry, and what are the different kind of applications which we have developed in case of hospital industry and agriculture industry. That I'll try to explain you. This is what training algorithm. As I told you that there are three kind of different kind of learning scenario, learning style: supervised, unsupervised, and reinforcement. So when you have the label data, you can go for the supervised learning. So there is a different set of algorithm as available for you, and that is known as, these algorithms are known as supervised learning algorithm. And when you don't have the label data, means the target data are not available along with the input data, so you can go with unsupervised learning. So again, you have a set of algorithms available for you that you can use in case of this unsupervised learning. And reinforcement learning is a little different. It learns from knowing the error. Okay, so if like see a child, if you are training a particular child, and if the child is doing some mistake, and if you are giving penalty to that particular child, so through that penalty only that particular child can learn. So this is sometimes it is known as penalty based learning. So the reinforcement learning is also nowadays very important, and it can be used for developing any machine learning model. Friend, as you know that this for developing any machine learning model, you have the different like tools and techniques available for you. And see, if you don't have any programming skill, you can go with some software. where we need not to write any program, and you can develop your AI model for any application or any use case or any problem statement of your Industry 4.0. So these are MATLAB. MATLAB is one software from MathWorks that you can use to develop your AI model. And the second is many open source softwares are also available. So you can develop your model without writing a single line of code, in fact. And the Veka that is developed by Waikato University, Australia, New Zealand, sorry. And that Veka you can use to develop your AI model. And if you know the programming, the very powerful programming language which is available for you, that is Python. So using the Python also, you can develop any AI model. So if you are interested with the technology stack, these are the available options for you, and you can develop your model, a machine learning model, with the help of all these like tools and techniques. See, now we are switching from traditional machine learning to advanced machine learning technology or techniques, and it is known as deep learning model. So what happened, when we have high dimensionality data, like when we talk about image data, when we talk about this video data or this audio data, the number of features are very high. In fact, in that particular case, the traditional machine learning techniques are not efficient to develop any machine learning model. So if you have high dimensional data, thousand or millions of features are there, dimensions are there, in that case, the traditional machine learning fails. In that particular case, what happened? We have to think about advanced machine learning model, and that advanced machine learning model, just wait. That advanced machine learning model is what? That is deep learning model, deep learning techniques. Okay. Now let us see one scenario where the classification can be done. Once machine learning model can be developed by feeding the historical data, and by checking the performance of that particular model, our classifier can be developed, and that machine learning model will is known as classifier. So if this classifier will receive a particular sample or particular product, it will identify on the basis of the knowledge which the classifier has acquired during the training process, and it will classify that particular sample or that particular object as good quality of product and poor quality of product. So this kind of classification can be done by the machine learning model. So friends, as I told you that there are certain limitations of traditional machine learning, and one of the limitation is that if in case of high dimensionality data, when the number of features are very high, which happens generally in case of image data and video data. So our traditional machine learning model cannot simulate that high dimensionality data, and the model which will be developed using this high dimensionality data, that traditional machine learning model cannot predict efficiently, or cannot simulate the data of high dimensionality. In that particular case, we can have another machine learning techniques which are known as deep learning techniques. And one very important aspect of deep learning technique is that It has the automatic feature extraction capability, which is not available in the traditional machine learning algorithm. So in the traditional machine learning, we have the handcrafted feature extractor. We have to apply some algorithm to extract the features from a particular object or a particular data, and then we give it to the any algorithm, and we get the output. So these two important problems can be overcome with the help of deep learning. And as you can see that deep learning is advanced machine learning techniques which are widely used nowadays, and has the it provides a flexible, learnable framework for representing uh, audio data and video data, as well as this image data. And as I told you that this deep learning techniques are having the automatic feature extraction at the different levels. So it has the very deep layers of artificial neural network, which plays very important role to extract the features from the object. Automatically it extracts the features, and it reduces the features also from layer to layer, and then it gives the output. So this is what uh, the difference in between traditional machine learning and deep learning. So when we talk about the deep learning, we have a very powerful architecture of deep learning, powerful architecture of neural network that is known as convolutional neural network. And we have recurrent neural network also, and there are different variants of CNNs which are available for you. The different scientists have suggested different kind of uh, different variant of convolutional neural network. The convolutional neural network is having a certain process and certain steps and certain layers, and that each layer of CNN has its own characteristics. It has its own role, and this architecture can be architectures are changed from one variant to another variant. So these variants are available for you, and there are different architectures which are very powerful and very efficient for a particular type of data. Say, for example, VCCNet is very powerful for the image data processing. So in Industry 4.0 also, you can have the different kind of image data, and that can be simulated very easily in case of convolutional neural network or different variant of convolutional neural network. So there are some mantra of deep learning is increased availability of data, significant improvement in computing power, model size increases, and new way of learning representation. So these are a different kind of mantra of deep learning. And the major areas and application includes image classification, object detection, image caption and labeling. You can have a particular image, and the captioning can be done by the this deep learning model. Videos activity detection can be done, like in CC camera. The activity detection, intelligent activity detection is also possible. And very important thing is that the medical image data processing, like X-ray image or MRI image, and this ECG images, these images, medical image data can be processed very easily and efficiently, effectively with the help of this deep learning architecture. And deep learning can also be used for the text classification, machine translation, like see like your Google translation. It can translate one language into another language, so that is very easily it can be done with the help of deep learning. So this is just architecture of multi-layer deep learning architecture, where you can have the different layers, input layer, and then hidden layers, and then output layer. The layers, one layer is connected with means all the neurons of one layer is connected with another layer, so that the signal can be propagated from one layer to another layer, and ultimately you get the output. Okay. So this is how this machine learning or artificial neural network actually works to simulate your data. And these are the technologies which are available for you to make an industry as Industry 4.2. So the very important technology that is Internet of Things, which we have already discussed. And in IoT, you can have the sensors in the machines, so that you can capture the like activity of that particular machine through the sensors, and that data can be captured. That captured data through the sensors of the machine can be analyzed using the different data analytics tools. You can have the real-time production monitoring, what kind of production is going on, that can be monitored in the real time. Predictive maintenance can be done. So by integrating IoT in industry, you can have the different kind of benefits. And that artificial intelligence and machine learning, as I told you, that you can integrate this machine learning and AI in Industry 4.0 for intelligent decision making, the like say demand forecasting, and the quality of the product, for checking quality of the product, and for forecasting, demand forecasting, and other things. You can use artificial intelligence and machine learning. And for the automation, the robotics can also be used in Industry 4.0. In many industry, you may find that robots are working, especially when you have the repetitive works. That repetitive works can be done very efficiently and effectively by the robots, in fact. So you might have seen robotic arms in this industry, which works, which performs a repetitive works, in fact. So the robotic arms and robots are widely being used in industry, so that the performance of industry can be improved, and efficiency of the product can also be improved. So let us take a scenario of Amazon warehouse. In Amazon warehouse, a lot of robots are there. In the different floors, you will find the different robots. And the moment a particular customer give order of particular products, the entire process is being done by the robots itself. So there is entire process of selecting a particular product from a particular shelf, and putting it on a particular box. All the entire process is being done by the robots. So there is a revolutionary use of robots in Industry 4.0. So different in the robotics, if you go inside the robotics, you'll find a different kind of robots are there. And these robots plays very important role for doing a particular task in industry. The 3D printing is also a very important technology which are used in Industry 4.0. So for additive manufacturing process, the 3D printing is used. Suppose you want to have some before producing a particular product, if you want to visualize that particular product, how it will look like, so that can be designed with the help of a particular software, and you can give that particular model to the 3D printer, and 3D printer will produce a three-dimension object for you. So it builds object from layer by layer, or and you can design your image, digital image, and then you can give command to the 3D printer, and that 3D printer will produce the replica of the product which you are going to produce through a particular machine. So before producing a particular product, if you want to look, if you want to feel how that particular product will look like, so that you can you use with the help of 3D printing. Say for example, like see, if you want to produce a human organ, suppose you want to produce a heart of a human being. So there are certain layers of heart, so that you can design in a particular software, and you can print a 3D heart, in fact, through the 3D printer. Likewise, any of the products you can design and then you can print with the 3D product. So the 3D printing technology is also widely used in Industry 4.0. So that is what you can develop the prototype of the product. The rapid prototype development can also be possible with the help of 3D printing. Customized production you can do, and you can have the complex product design, which is not possible in the traditional method, that can be done with the help of 3D printing. And the cloud computing is also a technology which can be integrated, and which is important to integrate in Industry 4.0, where the data can be stored for the remote accessing, and all the industry related data, whether the data is related to your machine, related to your production, related to your ERP, all the data you can store in cloud, and that can be utilized from anywhere. So that is what a centralized data storage, and this centralized data storage can be monitored or can be utilized from the remote place also. So the cloud computing is also very important in case of Industry 4.0, and this is important and this is necessary to integrate it when you are talking about AI based Industry 4.0. So the cloud computing must be integrated in that. And sometimes you need to analyze your data, very complex kind of data if you are having, and you need to analyze those data. You want to analyze the daily production and the category of the different production. So all this kind of analysis you can do with the help of different data analytics tools. So the big data and analytics is also very important to visualize the production process, to visualize the production data. So as per the requirement, you can have the data analytics also. So there are different data analytics tools which are available to you, and that can be used for data analysis also. So in the Industry 4.0, we are talking about a smart manufacturing, where everything will be smart. And we talk about the digital twins for simulation, predictive maintenance, smart assembly line with robot, automated quality inspection using AI. The quality inspection can be done. So when we are going to integrate all this technology, so the entire manufacturing or the production process will become smart manufacturing. And a smart warehouse and logistic is also possible with the help of AI and robots. So smart warehouse means the searching of a particular product from a particular warehouse can be done very easily with the help of AI. The packaging can be done on the basis of the size of a particular product. The packaging can be done with the help of a particular box. So the size of the box can also be identified by the AI, and the product can be kept inside that particular box. So all this particular process can be done with the help of AI and machine learning. So that is what is smart warehousing and logistic can also be done with the help of AI and machine learning. Healthcare application is another industrial application where we can have the remote patient monitoring and AI assisted medical diagnosis, which is very, very powerful nowadays. The doctors, even the specialist doctors, they are using this AI assisted medical diagnosis. The interns, medical interns, are also using AI based diagnosis system. Robotic surgery is also very common nowadays. Smart hospital automation is also there. And in India itself, you will find that the smart diagnosis system is very widely used in Europe and America. This is very common. And nowadays, we are talking about AI assisted medical diagnosis. And AI assisted medical diagnosis means what? You can have the machine learning model developed with the help of particular historical data, and that model is tested and then it can be deployed in the real sense in the hospital. So the hospital industry is also like the industry 4.0. It's a part of industry 4.0, where we are talking about artificial intelligence and machine learning and IoT and cloud-based technologies are integrated in healthcare industry also. The smart agriculture is very emerging industry, in fact, nowadays, where we are talking about agriculture in the smarter way. And we are talking about the precision farming with IoT sensors. We can have the IoT sensor in our farm, and it will analyze the data, and it will propagate the data in the server. And in the server, there is machine learning algorithms are there, and for a certain decisions, the data receives by the machine learning model, and the decision has been taken by the machine learning model. So this is also very common in Europe. In fact, precision farming with IoT sensor and drone-based crop monitoring is also very common nowadays. And drones takes the pictures of particular farm and sends the data to the server, and the machine learning model takes certain decisions. So the crop can be monitored with the help of drone cameras, and automated irrigation system is also there. Livestock tracking using wearable devices, that is also possible. So the agriculture industry is now becoming very, very smart. And in energy saving also, you can have AI based energy saving techniques where you can have IoT technology also. So in energy optimization is also very important in different industry and factories, in fact. So how we can minimize the use of energy, in fact, that is possible with the help of AI. Renewable energy forecasting is also possible. And in the retail and customer, it is also, you can use AI techniques. And the construction and infrastructure also. Nowadays, you'll find that 3D printing for building. You might have seen that you can design a particular house in the construction, and there are some machines which prints the house itself. So that is 3D printing of building. So the building can also be printed using the machine. So you design a particular house, and the house can also be printed. So drone-based site inspection, instead of having the human inspection, the drone can do the inspection whether the construction is going well or not. So that in the construction and infrastructure industry also, this technology can be used. So friends, as I told you that how the Amazon actually works. So in Amazon warehouse, there are a lot of robots are there. AI techniques are being used. Machine vision, computer vision are being used. And without human intervention, a lot of most of the works are being done by the robots itself. So the goal of this Amazon is to deliver the product, deliver the product as soon as possible to the customer, and processing the order in accurate way and in the faster way and in efficient manner. So that is what the overall objective of the Amazon. So there are certain steps how actually Amazon warehouse works, the workflow of the Amazon warehouse. Receiving and scanning, then storage using random store, robot move shelves. The Kiva system, one Kiva system is being used by the Amazon. Order picking by worker, automated packaging is done by the robots itself or by the automated machine. Sorting and routing, last mile delivery. So these are the certain steps how actually the automated system in the Amazon warehouse actually works. So the detail of this each step is given over here. So these are the technology stakes of the Amazon warehouse. So AI is there, robotics is there, robotic technology is there, cloud technology is also there, IoT is also there. So all these technologies are integrated in the Amazon warehouse, and this smart warehouse management of Amazon is very, very powerful. And the problems which are available in the traditional warehousing system can be overcome with the help of this smart warehouse management system. Now, friends, let us come to the hospital industry, and I'll tell you that how the models can be developed. I'll take inside of the machine learning model so that you people can understand how the actual machine learning model can be developed. You might have seen this particular scenario, this particular picture during the COVID-19, where the robots were working in the hospital. Okay, so these are the very common scenario during the COVID, and we have worked a little bit during the COVID for the hospital industry, in fact, and see, we have during that particular period we have developed one machine learning model, and the name of that model was Covis Health. Okay, so what we have done, see, as I told you that whenever we are thinking to develop any machine learning model, you must have the data. But during the COVID-19, we could not find any data, COVID infected data. At the time, the data are not released by the government of India, in fact. And anyhow, we have received some data from the repository of the Chinese COVID patient. And the data size was very small, in fact. Friends, as we know that whenever we are talking about machine learning, development of any machine learning model, you must have huge amount of data. So the intelligent level of a machine learning model depends upon the sample size, the data which you are going to use to develop your machine learning model. If you have very small size of data, and that small size of data you are going to use to develop your machine learning model, then maybe possible your machine learning model will not become more intelligent. So at that time, we have very small size of data. I think it was 400 something data were available of COVID-19 patient, in fact. So anyhow, we have collected that data, and we have tried to develop a model, because this is chest X-ray image data were there. So this is image data. So we have decided to develop a machine learning model using deep learning techniques. So because deep learning technique is very powerful to process image data, in fact. So it can see inside the image data very easily, and it can extract the features of the image data. So it automatically the feature extraction capability is there of any machine learning, any deep learning model like CNN and LSTM. So we have decided to use CNN, different variants of CNN, and in fact we have used VGG19 and other variant of CNN model to develop machine learning model for classification of COVID-19 patient, whether a particular patient is having COVID-19 positive or COVID-19 negative. So on the basis of chest X-ray image, we have developed this particular model, and we have tried different variant of deep learning technique, in fact, and we found that the techniques are like working very well. And one more thing we have done in this particular model during the model development, we have used XAI. XAI, friends, this is whenever you are thinking to develop any machine learning model, you can integrate XAI, that is explainable artificial intelligence. So like see, in a particular architecture of your deep learning like CNN, you can integrate XAI somewhere in between, and it will tell the detail about the prediction which is being done by your machine learning model. Say for example, if your machine learning model is telling that yes, if you are giving a particular X-ray image to your machine learning model, and if your machine learning model is telling that yes, the patient is having the COVID-19 positive, so now sometime you may ask that how can you say that I'm having COVID-19 positive? So your model can explain that due to this particular reason, I can say that you have COVID-19 positive. So if some explanation are required, if uh, if the machine learning model is predicting something, and if you need some explanation of that particular prediction in order to justify the prediction, you can have XAI. So we have integrated explainable AI also. So these are the data sample which we have retrieved from the repository, Chinese repository, in fact. And I think this COVID-19 positive data are there. 349 samples are there, and 397 samples are there of normal data. So in total, there were 746 samples. Again, I am telling you all that this much of samples are not sufficient to develop any machine learning model. For any industry application, you can have a huge amount of data. As much as possible, you can have the data, and then you develop the model, and then only you can rely that machine learning model in the real scenario, in the real time scenario. So if the number of samples are less, you cannot rely that particular model. So you have to think about huge amount of data. You have to collect, you have to retrieve huge amount of data to develop any machine learning model. Because at that particular time, we could not find a huge amount of data, and we have only 746 samples. And using this 746 samples, we have developed the model. These are the performance of the model. With different models we have used, and we got 96.6% accuracy. And in case of another machine learning, another deep learning model, the accuracy was 98. In case of BGG19, we got 99% accuracy. So these are the performances which we got at that particular time. And we have satisfied that yes, the model is even we have very less amount of data, but the model was working very well. These are the findings in a graphical manner. And then we have developed one particular software, and the name of the software was Covis Health. And this particular paper is published in SCI also. And what this software does, you can have one X-ray image data of any patient, and that you can put, you can upload, even you can upload single data also, or you can have the multiple data of the multiple patient, in fact. And once you'll click start diagnosis button, it will predict whether the particular person is COVID-19 infected or not. Friend, during the COVID-19, we have done the forecasting also. What will be the scenario of the like COVID-19 positive tomorrow or after 1 month? What will be the death cases? What will be the recovery cases? That also we have done. So this kind of forecasting you can do for any kind of problems in case of Industry 4.0. So these are the findings, like sentiment analysis. Sorry, we have done sentiment analysis. What was the sentiment of the citizen of India during the COVID-19? So the before lockdown, this data, in fact, we have taken from the Twitter. Okay, at that time, you can fetch the Twitter data without any charge. But nowadays, if you want to fetch the data from the Twitter account, you have to pay something. So this is the sentiment analysis we have done at that time. So before lockdown, just you can see the positive, negative sentiment. The red is negative sentiment, and the green bar is for representing positive sentiments. And after lockdown, the negative sentiment increases and the positive sentiment comes down. And this lockdown 2.0, lockdown 3.0, and lockdown 4.0. So these are the situations. So this kind of sentiment analysis also we can do with the help of machine learning techniques. We have done global sentiment analysis also of 7 countries: France, India, Italy, Spain, UK, and USA. Like sentiment related to COVID-19. So that also we have done, and this is the result of all the 7 countries. Here in the left side, you will find the negative sentiment of France, India, Italy, and other countries. In the right hand side, you will find the positive sentiment also. So this sentiment analysis we have done. And the forecasting, COVID-19 cases forecasting also we have done. So this data we have gathered from the Ministry of Health. In fact, during the second lockdown, we have done this particular project, and we have retrieved the data from Government of India, Ministry of Health, confirmed cases, recovered cases, and death cases. So we have tried to forecast all these 3 different cases. What will be the confirmed cases, COVID-19 confirmed cases, and what will be the situation of recovered cases tomorrow or day after tomorrow, and what will be the death cases. So these 3 different cases, for these 3 different scenarios, we have developed machine learning model, and various data pre-processing we have done. As you know, that data pre-processing is very important part of your machine learning model development. And ultimately, we have pre-processed the data, we have extracted few features, and then we have fed this data to our machine learning model. And I can show you the result. This is the result. If you remember that on 15th April 2020, the actual COVID cases were 12,370 in India, and our model has predicted 12,880. Like, so the error was very less. In fact, the total means percentage error was 6.053. So at the day by day, just you can see the actual COVID-19 patient in India and the predicted by our machine learning model. So as I told you that whenever you are going to predict something using like machine learning, you will get the most accurate result as compared to any other techniques. So in case of Industry 4.0 also, we need to predict many things, like suppose like the depreciation of a particular machine, that can also be predicted. Fault which can be generated in the near future in a particular machine, that can be predicted. So there are different scenarios where you can use this machine learning technique for the prediction. And this is the result of I think it is recovered cases. So as you see that on 15th April 2020, the actual recovered case was 1509, and the model has predicted 1602. So again, the error is very less. So this kind of model just you can develop. See, as you know that the prediction is very uncertain. In fact, whatever you are going to predict, that is whether you are going to predict any stock market, whether you are going to predict any strength of a particular machine, a depreciation of a particular machine, or the fault of a particular machine, that is very, very uncertain, in fact, and that is what you can say non-linear process, in fact. So wherever the non-linearity is involved, like all the statistical technique actually fail, and you cannot use this statistical technique in case of prediction of any non-linear situations. In that case, this artificial neural network techniques are very, very useful, and hence you can develop machine learning model with the help of any artificial neural network techniques. These are the graphical representation of the work which we have done. So I'll not go inside all these works. So in the depression identification also we have done on the basis of the voice data. If you speak something, we capture your voice, and through that voice data, the machine learning model can identify whether you are depressed or not. So that kind of machine learning model also we have developed. So this is the entire process of developing your decision support system, depression identification, depression identification decision support system. So the data is very important again. So we have collected the data, we have pre-processed the data, we have extracted the feature, we have selected the important feature by using some algorithms, and then we have developed the classifier, and then we have done the validation. So these are the entire process, and these are the findings. The different machine learning algorithm like random forest, XGBoost, K-Neighbors, SVM, decision tree, MLP, multi-nomial, naive bias, logistic regression, ADA-boost, gradient boost. These are all algorithms which are available to you to develop any machine learning model. You have to choose which one is the best. So the trial and error method you can apply. In bulk, you can use this machine learning algorithm, and then you have to identify which machine learning algorithm is performing better, and then you can keep that particular model, and you can discard other model which are not performing very well as compared to this particular machine learning model. So these are the findings. And this is the software which we have developed for the depression identification. It takes your voice as input, and then it will identify whether you have depressed or not. This is another work which we have done. I will not go inside because time is already over. So in hospital industry, this machine learning based disease diagnosis is very, very common nowadays, and it is very, very powerful. In fact, it depends that for which particular disease identification you are going to develop your decision support system, in fact, and how efficiently, effectively, and in what manner just you are going to develop that machine learning model. It all depends upon the machine learning developer by selecting the data, and by pre-processing the data, by choosing a particular suitable algorithm for that, and by applying some feature selection and feature extraction technique also. This is another work which we have done, and for the multiple disease, for the cancer and for diabetes, we have developed an integrated software, in fact. And again, we have acquired the data from the repository. We have done the pre-processing. We have developed the model using the various machine learning algorithms, and we have evaluated the performance using the various performance measures, and then finally we have selected the best machine learning model to develop our CDSS, that is clinical decision support system. So friends, there are different situations where you can use other than this machine learning technique, and these techniques are like evolutionary computing also you can use. That evolutionary computing, when you are thinking about the optimization, like suppose energy optimization, so you can have a genetic algorithm, you can have other evolutionary computing algorithm that can be integrated with the help with machine learning, and so that it can learn the things also, it can predict the things, and it can optimize optimize the scenario also. So that kind of integration is also possible. This is the work which we have done by integrating genetic algorithm and artificial neural network together for the disease prediction, in fact. And just you can see that by integrating two different techniques, which are actually known as soft computing techniques, by integrating the two techniques together, you can have the like characteristics of both the techniques, and you can take the benefit of both the techniques, in fact. And this result reflects that yes, the combining genetic algorithm and artificial neural network together for the disease prediction, the result is higher than the individual technique. As you can see that 98.81% accuracy we are getting, and the precision is 95.8, recall is 100%. So this kind of thing you can also do for developing. While developing your machine learning model, you can think to integrate different soft computing technique also. Like fuzzy logic is another soft computing technique which is used for incorporating human reasoning, like what actually you are thinking. That thinking behavior can be modeled with the help of fuzzy logic. In 1965, the fuzzy logic was introduced by Latif A. Zadeh, and it is very, very powerful techniques. And in many industrial applications, the fuzzy logic can be used in power system also. The fuzzy logic based monitoring and fuzzy logic based optimization can also be used. And this fuzzy logic can also be integrated with the help of machine learning, traditional machine learning, as well as advanced machine learning like deep learning. So integration of the techniques are also possible. And this is the software which we have developed. So this is another work for the hospital industry. We have developed machine learning and optimization technique for early diagnosis of cardiovascular disease. So this also we have done. These are all technical parts, so I'm not going inside this. So just you can see the results, that various models we have applied. Some of the models are like pre-trained model, and these are the results. And we have done the hybrid of genetic algorithm, logistic, and CNN model, ResNet 15, and then you can see that the performance of hybrid model is very well as compared to any individual model. So this is the situation. So at various situations, you can integrate the various techniques together. So in agriculture industry nowadays, we are talking about the precision agriculture. So crop crop monitoring you can do, like see suggestion of like on the basis of the soil quality, you can suggest the crop also. That is also possible with the help of AI. And pest detection and the weather prediction is also possible. Like disease identification through the leaf of a particular crop can also be done with the help of AI. And we have done a lot of works in for the agriculture industry also. We have developed a lot of models for the agriculture industry also. And it is very, very powerful. AI technique is very powerful in case of uh, precise agriculture, for the precision agriculture. And in different like scenario or different problems in the agriculture industry can be solved very easily with the help of machine learning. So crop disease identification, as I told you, using machine learning. Fertilizer recommendation is also very important. Like, so you can suggest a particular component, a particular composition of NPK also. So that can be done with the help of any evolutionary computing or optimization techniques. So fertilizer recommendation, where in which particular for which particular farm or which particular crop, what kind of fertilizer is very important. So that can be done with the help of machine learning. So the agriculture industry also, health prediction is also done with the help of machine learning. Soil management also a very common application of agriculture, precision agriculture. So these are the different like scenario where in agriculture sector where the machine learning can also be used. So this is all from my side, and I have tried to explain the basics of machine learning and its industrial application. And I have tried to explain you that in hospital industry and agriculture industry, what are the different scenarios where machine learning can be used, and how this machine learning models can be in fact developed, and what are the certain steps for developing this machine learning model for any industrial application. This is all from my side.
Participants, any queries regarding this session? May I ask, please?
Good
Sorry,
evening,
doctor.
sir.
Sorry, doctor. We are running short of time. We have only 3 minutes. We have scheduled the meeting up to 9:15. So within 2 minutes, whatever can be done, I have to give one instruction. Kindly log with your laptop. Your mobile phone are not allowed for test. Test is due to be held tomorrow. You can do the personal message to me if I need to persist, but the mobile is not allowed. You don't think that you log in on ATAL portal on mobile and you go on assessment section and you can click there and you can solve the questionnaire there. Please note it. Thank you.
Please ask question.
Sir, good evening. Hello.
Yes, please ask question.
Sir, for machine learning mechanism, how much data required for the training purpose?
It's all depend upon your problem, in fact, but the sample size should not be very less, in fact. So
Okay.
and the second thing is that you may have such amount of data so that your model can perform very well, and you'll get the better performance from that particular model. So 1,000 or 10,000, these are very small size of data when you are talking about the machine learning model development.
Okay,
So you
sir.
can have the huge amount of data, in fact. And
Mhm.
sometimes we don't have, like suppose you are having X-ray image data, and if you go to the hospital, they will not provide the data to you. In that case, what happened? There are various repositories are available. From that repository, you can get the data. In fact, and
Okay.
one more thing that is possible, that data augmentation is also possible. So from the available data, you can scale up the data from 1,000 to 10,000, from 10,000 to 1 lakh. You can scale up your data with the help of data augmentation, so that there are different data augmentation techniques are available. So by using that data augmentation technique, you can improve the size of your data, and then you can use that data for developing your machine learning model.
Thank you. Thank you so much, sir. Thank you.
So, Professor Dr. Hota sir, your session was very informative with highlighting data, features, algorithm, machine learning applications, classifications through ML prediction and objective detection, learning algorithm, three broad categories of learning, semi-supervised learning, limitations of traditional ML systems, advanced machine learning models, uses of deep learning, recent trends in neural network, convolutions, convolutional neural network, deep learning success mantra, new training method, multi-layer NNS, Internet of Things in manufacturing, robotics and automations, 3D printing correlated with Industry 4.0, additive manufacturing through 3D printing, cloud computing, Industry 4.0, smart manufacturing, smart warehousing and logistics, health core application, smart agriculture by Industry 4.0. And I appreciated that in the agriculture sector, your innovative work and research work is going very favor with the nation in automotive and transportation, construction and infrastructure, and so many more, sir. So thank you so much for your informative session, sir. Have a nice day. Good night, sir.
Thank you to all of
Sir,
you. Thank you.
Sir,
Thank
if you are comfortable to share this content, so we can have some preparation for the tomorrow's.
Yeah, this PPT,
Yes, sir.
I'll share. No issue. I'll
Okay,
share.
sir. Thank you.
Thank you, sir. Thank you, Huda, sir.